Our sun regularly goes through periods of upheaval. Researchers have wondered why for decades. At the moment, things are fairly quiet, but activity is increasing, and what are known as flares are occurring more often. Flares are huge eruptions of radiation that explode with an energy equivalent to billions of atomic bombs, like in the autumn of 2003, when the sun spit a vast cloud of plasma towards planet Earth. The high-energy particles from the burst ploughed into the Earth's magnetic field and electrically charged the outermost layer of the atmosphere, with serious consequences. Satellites shut themselves down. Electricity went out. Radio and television programs were disrupted. And airplanes were grounded or had to be rerouted. Researchers at the Max Planck Institute for Solar System Research are trying to find out exactly how solar flares and their accompanying ejection of solar matter develop. They want to create a model to predict them, which would help protect satellites.
We have to learn more about the solar magnetic field. The ejection of mass, the flare, is caused by a buildup of energy in solar magnetic fields, for example, in areas of activity. We want to learn more about what happens there, which is why we need to better understand the magnetic fields in the areas of increased activity.
But the sun's overall magnetic field can't be detected from the Earth's surface. The Earth's atmosphere blocks observations. And additionally, the sun's magnetic field is in a constant state of flux, especially around the sun's equator, where the magnetic field lines form immense loops that can stretch far out into space. Only probes like the Solar and Heliospheric Observatory, or SOHO, can observe the sun directly. But to come to any conclusion, the scientists first have to combine various sets of data the probe sends back to Earth. This image shows the sun in the ultraviolet region of the spectrum. The radiation is emitted by iron ions heated to around 1.5 billion degrees Celsius, which drift along the magnetic field lines, making them visible. But large regions of the sun are either hotter or colder and cannot be observed in the ultraviolet. In these areas, researchers have to look for radiation emitted by other ions. Regions of different temperatures can be observed at different wavelengths of the light spectrum. The individual observations at different wavelengths are like parts of a puzzle that, when combined, provide a picture of the whole. But the picture that the scientists have created with the help of the highly charged particles is still incomplete.
The particles follow the field lines like beads strung on a cord. If you have particles, you can see the field lines because they emit photons. But if there are no particles on the field line, as you can have magnetic field lines in a vacuum, then the field line doesn't glow and we don't see the magnetic field.
The researchers have already discovered that eruptions of radiation arise in places where magnetic field lines merge. The sun bubbles and boils in areas like these. Sunspots are often seen in areas like these. To the eye, the spot appears as dark points on the surface of the sun. The team at the Max Planck Institute have been looking at them more closely with telescopes here on Earth, and combining the data with images taken from space. That allowed the researchers to create a dynamic model. For the first time, they were able to simulate how magnetic fields in active solar regions change over time. That information helps them predict where a flare could be brewing and how hard it would slam into the Earth's atmosphere if it went up. Until now, they've had to work with static models called potential fields.
Unlike the potential field, this model tells us how much energy is brewing up, approximately. That means that we can identify regions that could be possible candidates for serious events, even though we won't be able to say exactly when those areas are going to blow.
To achieve precisely that, the team would need more detailed images of the magnetic fields. In the lab, they're already working on a new camera. On board of the Solar Orbiter space probe, the camera should provide them with the information they need. The Solar Orbiter, scheduled for launch in 2015, will circle the Sun closer than any earlier probe.